So we're talking about the periodic table and periodic trends, and we've discussed atomic radius, electronegativity, and ionization energy, and how we can use the periodic table to interpret these trends. And you know you got it if you can define these three terms, if you can explain the trends moving down a group and across a period, and if you can label the periodic table with arrows showing the direction of the trends. And in this video, I just want to summarize all three trends together. And I want to bring it back to this idea that the trends are related to the forces of attraction between the electrons and the nucleus. The stronger forces happen when there are less energy levels and there are more protons. So if I look at a periodic table, less energy levels is going to be higher on the periodic table, or a lower row number. So row 1 only has 1 energy level. Row 7 has 7 energy levels. And more protons is going to happen as we move across a row. So helium has more protons than hydrogen. Neon has 10 protons. Lithium only has 3. Now, with stronger forces, we're going to have stronger electronic properties, and these are going to be ionization energy and electronegativity. So I can actually summarize these two arrows into one large arrow for ionization energy and electronegativity. In general, the ionization energy and the electronegativity of atoms increases as I go from the bottom left of the periodic table to the top right on the periodic table. And that's because this is the direction of increasing forces of attraction between the electrons and the nucleus. Now, the opposite is true for the atomic radius. It has the opposite trend because atomic radius is larger when the forces of attraction are weaker. So having more energy levels puts the electrons further away, makes the atom bigger. Having less protons means weaker forces of attraction, and so the atoms will be bigger. And so ideally, you can now draw arrows on the periodic table to help you identify which direction the trend changes, but you also should be able to explain why the trend changes that way. And it all comes back to the forces of attraction. So let's take a look at some practice. Let's compare the atomic radius of N and P first. And what I want you to do is when you're actually trying to compare periodic trends, check how far down the elements are first, in other words, what row they're in, and then how far over they are, what column they're in. So I'm going to find N and P. This is nitrogen and phosphorus. Nitrogen is number 7. Phosphorus is number 15. So phosphorus is down lower than nitrogen. It has more energy levels. So I know phosphorus will be bigger than nitrogen. Okay, what about magnesium and chlorine? Well, magnesium is number 12. Chlorine is number 17. They're on the same row. If they're on the same row, then I can't compare the energy levels. So they're on the same row. Check how far down they are. Then how far over. Chlorine is further over. It has more protons, more attraction. This is atomic radius, so more attraction means smaller. Chlorine is smaller than magnesium. And finally, let's try an ionization energy practice. F and Br, fluorine and bromine. Fluorine is number 9. Bromine is number 35. Bromine is further down. It has more energy levels, less attraction. Fluorine is higher up, more attraction.